Good evening and welcome to the Q&A session 11 from the chapter of Gravitation. The topic is the areal velocity and its dependence on the angular velocity and the orbital radius. So based on this topic, I have one question for this session which is written here on this board. So in the planetary motion, the areal velocity of the position vector depends on the angular velocity, that is omega, and the orbital radius r. Orbital radius means the distance between the sun and the planet. So the correct relation for the areal velocity is, so we have been given here 4 options and we have to find the correct option. So in the session number 9, we have learned that the areal velocity, that is the dA upon dt, is equal to L upon 2m, where L is the angular momentum. So this angular momentum can further be written as, angular momentum is the moment of linear momentum, so this is equal to mvr divided by 2m. Here m is the mass of the object, v is the linear velocity, and r is the orbital radius. So from here, the areal velocity, that is dA upon dt, is equal to Vr upon 2, and now V is equal to R omega. V is equal to R omega, so I will be substituting the value of V as R omega. So I will be getting this equation as R omega into R divided by 2. So this is equal to R square omega upon 2. Or in other words, we can say that the areal velocity, that is d upon dt, is directly proportional to omega r square. So the correct option here is last one, that is D. That is the dA upon dt is directly proportional to r square omega. So in this question we have simply used the formula for the areal velocity, that is d upon dt is equal to L upon 2m, and from this equation we have been able to find the dependence of areal velocity in terms of this angular velocity and the orbital radius. So in the next session I will be coming up with a different type of a question from the same topic of areal velocity. Till then, have a nice day. Bye.